Yay. Okay, this is the first time me recording the session, so that's great. I was really never able to do that. Yeah. How are you doing?
Good.
Yeah. Okay. Do you think this, like, the ethers and everything is going good?
So far, a little bit, yeah.
Okay, so I was gonna, like, review everything, like, mechanism, and, like, give you a bunch of problems to do. Yeah. Okay. Okay, that's for you guys to sign. Okay. I guess the first one, let's just go over like the synthesis of ethers. Okay, and since this is very new, like you probably remember like the methods of synthesis, right? So there's 3 of them. What is the first one?
The Williamson?
Yeah. So we have Williamson, ether, synthesis. Okay. And what do you use here? Like, what do you have to use?
We start off with ROH and then RX.
Yeah, okay. Cool. So for this one, we have like 2 super important concepts that she will for sure ask you at the exam. So basically, if you have something like this, right? If you have an sp3 carbon, which is basically like this, right? And you have, so you start with an alcohol, right? And this guy is an sp3. Then your reagents will be like the base, right? But your reagents will be either sodium or sodium hydride, right? And then you use some kind of whatever, CH3 bromine, let's say. Okay? Hello. But if you have an aromatic ring, so the same, let's say OH. But if you have an sp2 carbon, right, then your reagents will be what? What will be instead of sodium or sodium hydride? Yeah, you have to use a hydroxide, okay? Right here. And then you can use CH3 and Br again. Hello. You're not taking organic chemistry too. I know that.
You're the TA?
No, I'm the SI. Yeah. Okay. So yeah, the difference between those is basically like you're still gonna get your ether, right? But your reagents should be different. Yes. And then, as you said, it's an SN2 reaction, right? So there's another, how can I say, another like restriction that we have to consider, and it is what? On reagents, restriction on reagents. This guy has to be a primary, right?
Yeah.
So, hello. So this guy, okay, it has to be a chain without any groups. So you can have something like CH3, CH2Br, right? It doesn't matter how long. Like you can have this is fine. But this Br has to be right here, okay? What you can't have is something like, you can't have anything like that, okay? Nothing bulky. Okay? And that's another restriction. So I'm just gonna write, so both of these are SN2 reactions. Okay. Any questions for that? Okay. Okay, do I have angry students yet? Not really. Okay, good. Okay, so this was the first synthesis. And then the second synthesis is what? So we did Williamson, and then there's two more. Yeah. Dehydration. Yeah, dehydration. Okay. She was calling it OROH. Dehydration is basically loss of water, right? So like remember that your water is gonna go away. Okay, and basically a cool thing about this, like the way you can remember it, is that it will always give you a symmetric ether, okay? Right? Because you're using two equivalents of the study, so it will always be a symmetric thing. So, yeah, you can use like and you can have something here, right? And then you have two equivalents of this, right? And you are using it with sulfuric acid. And this is delta, it's just like you're heating it up, okay? And so what would be the mechanism for this one? For the quiz, I chose that one as mechanism because it's like easy.
The oxygen takes the hydrogen from one of the H2SO4.
Right, so you have HOSO, right? So you said what is happening?
One of the electron pairs is gonna take the hydrogen.
And that leaves, right? So that gives you oxygen, hydrogen, and then what would be the charge in oxygen? You have positive, right? Okay. Okay, and what happens next?
The oxygen and the hydrogens pop off.
Because water is a good
Yeah.
leaving group.
Okay. But does that leave just like that, or does something happen there?
With the remaining, because you have two of the atoms.
Right.
So the hydrogen will leave that and add to the water.
So you have. Okay. So you have that. Yes. So yeah, that's right. So you have a second equivalent of this, right? H, right? So this guy is gonna attack here, and that's how it's gonna leave, right? So you are gonna have and then the same thing. So symmetrical one is gonna come here, and then you still have a hydrogen from here, right? So this is your positive charge. Good. And then you have a last step. What do you do?
With the H2O, it would take that remaining.
And then you just have your symmetrical. Yeah. So if you see something symmetrical, this is very easy. Like you just put this guy. Okay. Ooh. And then there is a last synthesis that we know. My favorite. Which one? Which one is it?
It's the one with mercury.
Yeah. So it's called. I don't even know how to spell it.
Alcohol.
alkoxy
Oxymercuration.
mercuration,
Demercuration.
and then mercuration. I never remember the name, but basically mercury, so you have the Hg. Okay. So you have, doesn't really matter what you have something like this, right? And then you have this group, for example, right? And then you treat it with Hg, right? OAC. Okay, what is the first step? What happens here?
Well, the OECs lose and then the HG attacks. No, the double bond attacks the HG.
Yeah, so so this guy comes here, this guy goes here, and this leaves, right? Okay, what is the stereochemistry for this one?
Either going outward or inward.
Yeah, so they are opposites, right?
Yeah.
So if, for example, this guy is gonna go up, right, so blah, 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 then this guy is gonna go the other way, right? Okay. And then you treat it with what? What comes next?
It'll be any CH3OH.
Will be an alcohol.
Yeah, alcohol.
Yeah, and we can have a CH3OH. What happens? What attacks what?
The oxygen attacks the less injured.
Which is up or down?
Down. That's from the top, but it attacks the bottom one. So it's less injured.
It's the other way.
Yeah, I believe it's
Yeah.
More substitute.
just because it's
Yes, the one that is more substituted. Okay, so this guy goes here, and this guy comes out, and then you switch places with this, right? So you are going to have here. You are going to have now this one, OCH3H, right? This is your positive charge here, and then you now this goes to the back, okay? And then you're gonna have 1, 2, 3, yes. And then you're having this guy here, HGOAC. Okay. Now you're getting rid of this like positive charge, right? So what you're gonna have is, so your alcohol is taking place here, and then you still have this Q3. HGOAC. Okay, and then your last reagent that you use is so you have an NADH4. What attacks what? Just a hydrogen, right? Like so, like that goes here, and this guy comes out. And then you are left with OCH3, and then you don't even have to write hydrogen because it's just a hydrogen, but so you know stereochemistry, this guy is here. Yeah. Okay. Cool. Okay, and then she discussed the reactions of ethers. So, okay. Let me just go. There's also a difference between those two. So So the first reaction that like she told you guys was the HBr, HCl, HI, right? Ethers react with those. So, but the problem is, for example, if you have something like this, let's see, OCH3, right? And then you're gonna have something like CH2OCH3, okay? And both of these are ethers, right? So they both can react with HBr. But that's also a key concept because there's a difference between those. And you guys tell me the difference. What is the difference between
Where the oxygen is in place.
So this is what kind of carbon? sp3 or sp2?
sp2.
sp2, right? And this is what kind of carbon?
That is sp3.
sp3, right? So the mechanisms for these are going to be different. So let me just write HBr, HBr, right? So for example, we start with the top one. What's happening? What is the mechanism for that?
First, the bromide will become negative, I believe.
Right, but what attacks what?
The bone pair on oxygen attacks
Yes.
the hydrogen.
Yes. So your electrons, right, are going to the positive, and this is a very good leaving group, so it leaves, right? And basically what you have is O, H, then you have your CH3, and this is positive, right?
Yeah.
Okay, and what is happening next?
The CH3 would split from.
Okay, so you have your Br minus like floating around, right?
Yeah.
So what it wants to do is, it wants to attack, yes, what?
Oxygen.
It wants to attack this carbon.
Yeah.
This guy comes here and this comes out, right? And so your final product for this guy is just an alcohol. Okay?
Yeah.
Whereas here we see a different situation. I'll draw an arrow down so like it's not confusing. So what happens here? The first step is going to be the same, right? Right? So oxygen goes here and bromine comes out, right? So you still have a CH2, O, H, CH3 positive. Okay, what happens next?
The bromide would attack either the CH2
The
or
sp3
Mm-hmm. Which one though?
the CH2.
the CH2.
Or is it the CH3?
The CH3. So we're gonna go to CH3, right? But now when you leave,
Oh,
CH2OH, okay? The problem here is that you still have another sp2, sp3 carbon, right? So the thing is, reaction here is not gonna stop, okay? You still have an oxygen that is active and you still have an sp3 carbon. So what's gonna happen? You go and get another hydrogen, okay? You still have like your H plus. So you do it all over again, okay? It wants to do that one more time. So you have that here, you have a CH2, and then you have your oxygen, hydrogen, hydrogen, right? You have a positive charge now. right? And now this water wants to do what? Leave, right? It doesn't want to be there. Okay. And so how do we make it leave? We have bromine, right? This guy comes here. This guy comes out. And what we have is CH2Br now. Okay? So, depending on what, if you have aromatic or NSP3, you're gonna get either the Br or you're gonna get an alcohol, okay? So be careful with that. So, okay. So these are the reactions of ethers. And then we did, okay, and then we did epoxides, right? So she told me she's not gonna ask you the mechanism for the synthesis of ethers, so you just really need to know what the thing is. So, not ethers, I'm sorry, epoxides. So what do they come from? Like which functional group we need to have?
Alcohol.
Really?
Wait,
Yeah, if you want to make an epoxide.
Alkenes?
Yeah.
Alkenes, yeah.
okay.
Yes. So we really want to have an alkene, okay? And then what do you treat it with?
MCPVA.
MCPVA. And then what you get is this guy. So you don't need to know the mechanism for it. That's what she told me. Okay. Okay, and if you had something like this here, yeah, then what would be the stereochemistry for this?
You have to do things up or down.
Yes. So they're going to be different, right?
Yeah.
So like if this guy is up, then these have to be down, okay? That's like the stereochemistry for it. Okay, and then she covered two reactions here. Today, the reactions of epoxide. And yeah, let's go. So, okay, so the first one she told you if you have basic conditions, okay? Right, so the first two reactions of epoxides were under basic conditions. And this is going to, we will be going to use the Grignard reagent here, okay? So you're going to have something R MgBr, okay? Now this is also important because the two reactions are different, right? So for the MgBr, if you are having an epoxide, and then so let's say you have O, and then you have something like this, right? And so your reagent is something, it doesn't matter what, so CH3 MgBr, and then you have an H3O plus, right? Okay, now here's, this is the key, like, it's very important what attacks where, right? So what's gonna happen? So because this is under basic conditions, your this guy is going to attack the one that is not like least substituted. Okay? So this one is important. And so, okay. Well, and this is gonna open, right? So you have this guy, you still have this guy here, and then you have basically a CH3 coming here, right? And then that guy opens, so your oxygen is here. Okay, but what is the stereochemistry?
The CH3 is behind.
The CH3 is behind,
The oxygen's in front.
the oxygen is in front,
And,
and then this guy is going
that
to be
one's
what?
behind.
Also behind, okay. Cool. And then next you treated with H3, oh well, you have a negative sign here, right? And so next you treated with H3O plus, so HOH2, right? This negative wants to get the oxygen and this comes out, right? And so what you have, so you have this CH3 here, and then you still have your OH here, and then this bulky group. Okay, so this is what you get for that guy. Okay, so this is one of them, and then the second one is gonna be under acidic conditions, right? And what kind of reagent we are using here? So like some kind of acid, so like sulfuric acid, or like it doesn't matter. So I usually just write H plus because it has to be an acid, and then you treat it with water. Okay. Yes. Okay. Okay. So if we have something like this, okay. Then you have your reagents, so H plus, and then H2O. What would be the first step?
The oxygen would attack the hydrogen.
Yeah. So you have that guy come here, oxygen, right, and you have a hydrogen here, and this guy is positively charged. Now, since I already told you that they are different, right, from the other one, now what's going to happen?
Attack the side that's more hindered.
Which is going to be?
The more substituted.
Yeah, and what is attacking? Water, right? So water now attacks the most substituted side, okay? And that's how it's different from the previous one. So what you have is, oh no, there's no ring anymore. Oops. Okay, so what you have is you have an oxygen H here, and then you have that guy and OH here, right? And then you have a positive charge. Okay. And what is the last part? Like, we want to neutralize this, right? HO. Yes, so we want to neutralize this, so you have again OH2. This one gets your hydrogen, and then we are getting OH here, and then OH here. Okay? And this one I'm going to say attacks the most. And you see the difference? Here we are getting like 2 alcohols, right? And then up here we are just getting 1 alcohol and then 1 CH3, right? Do you guys have any questions so far?
What did you say she was not gonna ask?
She's not gonna ask this synthesis of this, like the mechanism. She's not gonna ask mechanism for this guy. Okay, and now we can do some cool exercises. I have like a packet here. I think they're cool. Okay. So let's do number 1. So you need to provide the major organic product. So like similar questions to the quiz, right? Today, like you had to provide the major product, so you need to do the same here. So you're starting with this guy, okay? And then your reagents are, hello, CH3, CO3H, and then you have CH3MgBr, and then your last one is H plus H3O. Okay, let's do it step by step. Okay? Hello. So what happens after the first one? What is the first thing? What is this? Where's the thing? Sorry. It's called, huh? It's MCPDA.
Yeah,
Yeah, yeah. So what happens after you treat? So I'm just gonna go down and I'm gonna write 1. Okay. What happens after you treat the first one? You get the oxide that's over here. So oh, right? Good. And then what is the second and the third one? Like
reagent and the third one.
so we just covered it, right? So there's 2 reactions of epoxide that we covered. It was the under basic conditions or under acidic. And this one is
The basic.
basic, right?
Yeah.
Oh no, for the second one.
Yeah, that's basic.
Yeah.
Right. So if we treat the second one, right? So if it's under basic condition, then where is it gonna go?
The least.
Which is
On the right.
that guy, right?
Yeah.
Okay. So I can even write it so that it's understandable. So this guy is gonna come here, and this guy is gonna come out, right? And what we will get is oh, so this is gonna be minus, right? And then you have CH3. Okay. And then your third step is H plus and H3O, right? So what's gonna happen there? I mean, okay, basically these 2 reagents is the same thing, right? Because it's this guy. You treat it first with this, and then you treat it with H3O plus, right? So what happens? You have your OH2H, right? What happens? So these 2, let me, okay.
Is there mistake?
It looks like it's
I think there might be a mistake. It's the carbon chain on the right. Shouldn't it be attached
Yeah,
to
it's
the
attached
carbon
to
right row?
not an oxygen.
No.
Okay, one moment. Yeah. Wait, okay. Let me just rewrite that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right? And then you have this guy, and your CH3 comes here, right? Right, and then your oxygen goes here, with a negative sign. Yes.
Yeah.
Like that.
There.
Cool. So this is basically the same thing, right? You CH3MGBr and then you treat it with the H3O. Yes. And so your negative sign is gonna attract what?
The H.
Yeah.
Hydrogen.
Yeah, that was our mechanism, right? That we just did. So that leaves. And what you get is, so you have a CH3 and then you have OH. What is the stereochemistry?
Sure.
Huh?
Yeah.
So if I can go up here, under basic conditions, right? So your oxygen is up and whatever you attached is down, right? So this is going to be like the trans thing. So it doesn't matter. This can be up or this can be up. It doesn't matter. But what's important that these guys are trans, okay, from each other. Okay. Cool. Okay, let's do next. Exercise 2. So you need to show the best Williamson ether synthesis. Okay. The product that you have is this guy. Okay. And yeah. So how would you synthesize it with using Williamson ether synthesis? So you divide this thing by 2, right?
Yeah.
What is the restrictions on reagents?
It can't be tertiary for the BR.
No. No secondary either. It needs to be primary, right? So which one of the chains would give you primary?
The one on the left.
This guy, right?
Yeah.
So we treat this one as your primary 1, 2, 3, and this guy is going to be your bromine, right? Which means that the other one is going to be your what? Alcohol. Okay. OH. Okay. Now we need to pick the correct base, right? We have what kind of carbon it is. So you need to look at the alcohol, right? What kind of carbon it is? Is it sp3 or sp2? sp3, which means you need to pick what kind of base, which is?
NaH.
Yes. So you can either use an AH or an A. Hello. Okay? Cool. Any questions? No questions? Okay. Next. Okay, let's do similar things. So this is going to be first, the third one. Provide. Okay. So you have this guy, and you are getting this guy. Okay, what would be your reagents? So again, we divide this guy, we divide this guy by 2, right? And then this can also be by Williamson ether synthesis, and then again, limitations are what?
No secondary.
Right. And also we have this guy, which is what kind of carbon?
sp2.
sp2, right? Which means we can't, like, we want to have a primary. I mean, actually we can, but we didn't learn how to synthesize it yet. So you're gonna pick this guy as your primary chain, and you can have this guy as your alcohol, right? Yes?
Yes.
Okay. So you're gonna have this is going to be your DR, right? And then this is going to be your alcohol, right?
If they gave us the alcohol being a straight chain,
Huh?
but they gave the alcohol being a straight chain, so
What do you mean?
You wrote.
you wrote the straight chain being an alcohol.
Oh, okay, never mind. I did not see that. I was like, let's just synthesize this. Okay. Okay, then the other way. We have only one choice in this case. Okay, so we have to have this guy as DR, which is fine. It's just we didn't learn how to synthesize this guy yet, but it exists. Like, you can write that too. This is correct, right?
I believe so.
And that was using reacting with
Huh?
Br2H2.
What?
Isn't that benzene reacting with Br2H2?
No,
No? Okay.
no.
Um,
Because benzene is aromatic, so aromatic, like in order to attach bromine here, you need to have a different reaction. If you just have a cyclohexane, then Br2H would work and you would get this. But because it's aromatic, like we will learn aromatic reactions a little later, but it's okay. So you basically attach this guy, and what is your reagents again?
Na or NaH.
Yeah. Okay, cool. Okay. This is a 2-1. Oh, this is a nice one. Is this number 4? Which one is it? Okay, 4. So what you have is this guy. And then what you need to get is this guy. Okay. I like that one. Okay. So what is the two new things you can see at the, like on the product is the attached OH and CH3, right?
Mhm.
So it obviously came from what?
methoxide.
From an epoxide, right?
Yes.
And then there's two reactions that we know from epoxide, right? One gives this guy, and the other one gives everything attached, like on that side, right? So which one? So okay, let's just first write the reaction for epoxide. What do we do? MCPPA. And it will give you. So you already want to write the correct stereochemistry in this one, okay? So you know that your CH3 is down, so you're just gonna write CH3 down, right? And then the oxygen looking up, right?
Yes.
Okay. What kind of reagent will make sure to attack from this side so that oxygen comes that way? Which kind of addition is it? Basic or acidic?
Basic.
Yes, yes, okay. So basic comes from this one, right? And so what would be our reagent for this if we want to attach a CH3? So basic means something MGBr, right?
Yes.
So basically just like a CH3 MGBr, right? And what is the second reagent for this? We need H3O plus. Okay. And we can even write the mechanism, right? So this guy comes here, this guy comes out, right? So you have your CH3 here, then you have your O with negative sign here, and then you have your CH3 here, right? And then you treat it with HOH2. Your oxygen comes to hydrogen, comes out, and that gives you your answer. Okay? Questions? No questions, okay. Can go down.
Wait, just a minute.
Yeah, sorry guys. Actually should be right. CH3 and G3R H3O plus. Okay, and I have you guys done? Cool. And I have one last problem for you. You tell me how to do. Provide a structure okay. Br, okay. And your reagents are first you add magnesium, secondly you add a draw it here. H3C. And then third is H3O plus. Okay. Oh no. Okay. So when we do the first one, what do we get?
Same thing with just MGBR.
Yeah, that's the Grignard reagent, right? So we have that guy. Cool. Next we treat this guy with an epoxide, right? Okay. Is it acidic or is it basic?
Basic.
Basic. So where does attack what?
Left.
Which is what side? Left or right?
Right.
Right sides. And so yes, so we go, this guy comes here, this oxygen comes out, right? So we have CH, and then we have O minus here, right? And then we have carbon with the aromatic ring, right?
Yes.
And then your last one is again H3O plus, so you have HOH2. Your oxygen attacks hydrogen, this guy leaves, and you get your product. That does not go here, that goes here, sorry. And then you're gonna have OH. No, that definitely is not there. So but yes, that's how it is. Okay, and someone tell me what about stereochemistry? What's up with it?
Stress.
Should be trans.
Right. But okay, actually, yeah, she yelled at me for that. Like after, like in the quiz, I also like wrote as a trans, but you can't do it apparently. But it's correct. So you see how it's already giving you that this guy is up and this guy is down, right? Which means that everything else on this should be on the plane, okay? So even if these guys are trans, they both should be on the paper, on the plane, okay? So if you're already given something up or down, you just write these on the plane. So she doesn't yell at you. Yeah. Yeah, that's all I have. Do you have questions? Yeah. Thanks, guys. Did you sign my paper? Everyone signed it? Okay, I can stop the video, I guess. Oh no, you are showing. Okay.